500 tons of metal not should float. It is a physical absurdity, a mass equivalent to 100 elephants defying the gravity to 900 kilometers per hour. But what seems magic is, in reality, a masterly duel against the laws of the universe. Not it treats only of powerful engines, it is an invisible choreography between the pressure, the air, and the shape of a wing. Today we deconstruct from its beginnings the daily miracle that allows that a giant of steel treat to the earth as a simple suggestion. Let us take off. The 12 seconds that it all changed. The brothers Wright. At beginnings of the century 20, the race for the flight motorized was a puzzle with many pieces loose. Various inventors were close, but were two humble manufacturers of bicycles of Dayton, Ohio, who solved the equation complete. Wilbur and Orville Wright not were academics, but possessed a methodology impeccable and a perspicacity genial. They studied to Cayley and, above all, to Lilienthal. They understood that the great challenge pending not was only to get that something itself elevated, but to control it in the three axes of the space once it were in the air. While competitors like Samuel Langley, with the backup of the government Estadionidents, themselves centered in the power brute, the Wright obsessed themselves with the control. Their great innovation, fruit of the observation of how the birds fold the tips of their wings, was the warping by torsion of the wing. They designed a mechanism by means of cables that could twist or flex the tips of the wings of their biplane, the Flyer, for to incline the aircraft toward one side or other. This controlled the roll, the inclination lateral. For the pitch, to go up or to go down the nose, they used a small elevator in front of the airplane, a rudder of depth canard. And for the yaw, to turn to left or right, they incorporated a rudder vertical in the part rear. The revolutionary was that they connected the rudder of direction to the mechanism of warping, coordinating the movements for to perform turns smooth and coordinated, not chaotic. The 17th of December of 1903, in Kitty Hawk, Carolina del Norte, with winds strong and cold penetrating, all itself put to test. Orville himself lay over the wing lower, the engine of 12 horses of force gained life, and the apparatus of fabric and wood began to roll by a rail. At the end of the track, it itself elevated. The first flight lasted 12 seconds and covered 37 meters. It seems insignificant until that you understand what it signified. It was the first time that a machine more heavy than the air, impelled by its own power, performed a flight sustained, controlled, and, the most important, completely governable by its pilot. The Wright not only had flown, they had invented the protocol of control that in essence continues utilizing today each airplane commercial of the planet. Each time that a pilot moves the stick of control or the side stick for to veer, he is applying the same logic that those brothers applied with cables and pulleys, were 12 seconds that opened the door to all what came after. The evolution meteoric, from the fabric and the wood to the skies of steel. After the success of the Wright, the progress itself accelerated a form vertiginous. If the aviation had been a drip, it itself converted in a torrent. The first war world acted as a furnace of innovation forced. In question of months, the fragile airplanes of reconnaissance themselves transformed in fighters agile and bombers capable. It itself improved engines, it itself refined aerodynamics, and it itself developed instruments basic. The aviation left of to be a curiosity for to convert itself in a weapon, and in the process matured to steps giant. With the peace arrived a new ambition, to carry this technology to the service civil. The first flight commercial programmed of the history occurred the 1st of January of 1914 between San Petersburgo and Tampa in Florida. Operated by the line aerial St. Petersburg-Tampa airboat, the pilot Tony Janis transported to a unique passenger, the mayor Abram Fail, in a seaplane Benoit 14 during a journey of 34 kilometers that lasted 23 minutes. The ticket cost $400, a fortune for the epic. Not was a flight comfortable nor massive, but it was the spark. It demonstrated that the people was willing to pay for the speed aerial. In the decades following, airplanes like the Ford Trimotor and above all the legendary Douglas DC-3 converted that dream in an industry. The DC-3, introduced in 1936, was the first airplane that made that the transport of passengers were reliable and profitable without necessity of subsidies postal. It connected continents and defined the concept of the trip aerial modern, but the next jump would be quantum. Until then, all the airplanes used engines of piston and propellers. The de Havilland Comet, British, that entered in service in 1952, it changed all. It was the first airplane commercial to reaction of the world. The difference not was only of speed, although to double the speed of the airplanes of propeller already was revolutionary. The true advantage was in the altitude. The engines to reaction were efficient in air rarefied. The comet could fly by over of the majority of the turbulences meteorological at some 12,000 meters in the layer thin where the resistance of the air is much lesser. This offered a trip more smooth, more fast, and in theory more efficient. Despite of its tragic problems, initial of fatigue metallic that led to its redesign, the Comet marked the way. It had shown that the future was of the reactors, and so arrived the giants. The Boeing 747, the jumbo jet, presented in 1970, was another revolution, not by the technology of propulsion, but by the scale. It doubled the capacity of passengers, cheapening drastically the cost by seat and democratizing the trip aerial intercontinental. Of sudden, to fly to other continent left of to be a luxury for some few, and it itself converted in a possibility for millions. It was a city with wings. Finally, the Airbus A380 that flew by first time in 2005 represented the pinnacle of the engineering of fuselage wide. With 2 decks complete along of all its length, capable of to transport more than 800 persons in configuration maximum, it was a declaration of ambition technical. It demonstrated that even the limits of size could be redesigned. This evolution of the fabric to the composites of carbon, of 12 seconds to 12 hours of autonomy, is the fruit of an obsession that itself perfected with each lesson, with each failure, and with each triumph. The balance invisible, the 4 forces of the flight. For to understand how itself maintains in the air any of these colossi, from the Flyer until the A380, we must to speak of the framework fundamental. It is the grammar basic of the flight, established by Cayley and put in practice in each instant, are the 4 forces of the flight, and their interaction is a dance constant and precise. The first and most obvious is the weight. It is the force that exerts the gravity over the mass of the airplane. It pulls of it, without rest, directly toward the center of the earth. It is our enemy natural, the force that all design aeronautical seeks to counteract. Without nothing that to it itself opposes, the airplane is simply a projectile in fall. The second, the most mysterious and crucial, is the lift. It is the force that itself opposes to the weight. It itself generates mainly by the flow of air around of the wings and acts perpendicularly to the direction of the flight, toward up. It is the miracle engineering that converts a slab of metal in a bird. If the weight pulls toward down, the lift is the arm invisible that pushes toward up. How it itself generates exactly is a story fascinating that we will explore in depth, but by now, let us understand it as the result of the air interacting with the form special of the wing. The third is the thrust. This is the force that impels to the airplane toward forward. It is generated by the engines, already be propellers that screw the air or reactors that expel gases at great speed. The thrust overcomes the inertia and, the most important, allows that the airplane itself move sufficiently fast as for that the air flow over the wings and generate that lift. Without thrust, not there is speed. Without speed, not there is lift. The fourth is the resistance, also called drag. It is the force that itself opposes to the movement toward forward. It is the friction of the air against the fuselage, the pressure that itself accumulates in front of the airplane, the swirl turbulent that it leaves after of yes. It is the price that there is that to pay for to move itself through of a fluid. The more fast you go, greater will be the resistance. Now the magic of the flight stable not is in to eliminate none of these forces, but in to balance them. Imagine a scale of 2 plates perfectly leveled. For that an airplane flies straight and leveled to a speed constant itself must to reach a balance dual. The lift must to be exactly equal to the weight. If the lift is greater, the airplane ascends. If the weight is greater, the airplane descends. The thrust must to be exactly equal to the resistance. If the thrust is greater, the airplane accelerates. If the resistance is greater, the airplane brakes. A pilot, or the pilot automatic, is essentially a master of balances. For to go up, not only he pulls of the wheel, he increases slightly the thrust for to gain speed, what generates more lift, and then adjusts the controls for to direct that excess of lift toward up. For to descend, he reduces the thrust, leaving that the resistance gain momentarily, losing speed and by so much lift. It is a game of forces constant, a dialogue silent between the machine and the laws of the physics. This is the foundation. With this scale invisible understood, we are ready for to go deep into the heart of the mystery, to discover exactly how is that a piece of metal curved, the wing, achieves to generate the force magical that all it sustains, the lift. The secret is in the curve, how a wing manufactures force from the nothing. The lift. That is the word magical. Until now we know that it counteracts to the weight, but how it arises from the interaction between the air and a piece of metal. Not it is a single trick, but the combination masterly of two principles physical fundamental that work in harmony. The first is the principle of Bernoulli. Imagine a wing and cut transversal, its profile aerodynamic. Not it is symmetrical. The part superior, the upper surface, is notably more curved than the part inferior, the lower surface, which is almost flat. When the airplane advances, a mass of air itself approaches to the edge of attack of the wing and itself divides. A part flows by above, other by below. Here comes the key. The air that travels by the upper surface curved has that to cover a distance greater for to reunite itself with its companion in the edge of exit in the same time. For to achieve it, it must to accelerate. And according to Bernoulli, in a fluid in movement, an increase in the speed carries a decrease of the pressure. By so much over the wing, we have air fast and pressure low. Meanwhile, by the lower surface, the path is more straight and short. The air travels more slow and in consequence maintains a pressure more high. The result is a difference of pressure, high below, low above. The nature abhors the imbalances, so the area of high pressure pushes toward the area of low pressure, exerting a force net toward up over the wing. This is a source crucial of lift, but not it is the only. Here enters the second principle, the third law of Newton. By each action, there is a reaction equal and contrary. A wing not is passive. It is literally molding the universe to its around. Its shape and its inclination deflect a colossal mass of air toward down. Think in it. The wing, at inciting in the flow of air, it redirects toward the ground. The reaction to this action of to push air toward down is that the air pushes the wing toward up with a force equivalent. This effect of deflection of flow is particularly powerful when the wing is more inclined regarding to the wind. This inclination thus leads to the concept most important after of the shape of the wing, the angle of attack. It is the angle that forms the chord of the wing, a line straight from the edge of attack to the of exit, with the direction of the flow of air that itself approaches. Imagine it as the attitude with which the wing cuts the air. To increase the angle of attack, lifting the nose of the airplane not only increases the deflection of the air toward down, strengthening the effect Newton, but also accentuates the curvature of the path of the air over the wing, intensifying the effect Bernoulli. It is the control master of the lift. However, this power has a limit dangerous, the loss of lift or stall. If the angle of attack itself becomes too pronounced, the flow of air over the upper surface itself separates of the surface, becoming turbulent and chaotic. The lift itself collapses abruptly and the resistance itself shoots up. The airplane literally leaves of to bite the air efficiently and begins to fall. For that, the management of the angle of attack, especially in the phases slow of the takeoff and landing, is critical, and it is here where the engineering deploys its ingenuity most visible, the wings that themselves transform. Wings that themselves transform, flaps, slats, and spoilers. A wing fixed by perfectly designed that it be has a range limited of efficiency, not it can generate enough lift for to fly slow and secure in the takeoff and landing and at the same time to be thin and efficient for the cruise to high speed. The solution, to make it variable. It is like if a bird could to change the shape and size of its wings according to the necessity. For the phases of low speed, themselves deploy the flaps and slats. The flaps are panels in the edge of exit of the wing that, at extending themselves toward down and back, achieve two things. They increase drastically the curvature of the profile wing, powering the effect Bernoulli, and they amplify its area superficial effective. It is like to enlarge the wing momentarily. The slats are their counterpart in the edge of attack. They themselves slide toward forward, creating a space controlled that channels the air of manner more smooth over the upper surface, delaying the separation of the flow and allowing angles of attack more high without to enter in loss. This is vital for to land to speeds minimum secure. Together, flaps and slats can increase the lift until in an 80 or 90%, allowing that an airplane of 200 tons fly of form stable to barely 250 kilometers per hour. Once in ground, or for to control the flight, enter in action the spoilers, also called ailerons of combat or speed brakes. These are panels in the part superior of the wing that themselves lift. Their function is opposite, to spoil or to steal the lift. At interrupting the flow smooth over the wing, they destroy the lift of form controlled, transferring the weight of the airplane to the wheels for that the brakes work with greater efficacy. Also themselves use as brakes aerodynamic in the air for to lose height quickly without to accelerate in excess. The control of the roll, the inclination lateral for to turn itself, delegates mainly to the ailerons, which are surfaces mobile in the extremes exterior of the wing. For to veer to the left, the aileron left itself elevates, reducing lift in that wing, and the right itself goes down, increasing the lift, making that the airplane itself incline. This coordination of surfaces, inherited direct of the intuition of the right, is what converts a set of forces in a flight directed and elegant. The heart that roars, disentangling the engine turbofan. For that all this ballet aerodynamic occur, itself needs a force titanic that push the airplane through of the air, the engine. The dominant today is the turbofan of high index of bypass, a workmaster of efficiency. Forget the image simple of suction and expulsion. It is more precise to think in a gigantic fan moved by an engine to reaction ultra-refined. The process begins with the fan, the blades massive that you see to the front. This is the element most characteristic. Of each 100 kilograms of air that enter, around of 80 to 90 not go to the core of the engine. This is the flow of bypass or bypass. Simply, it is accelerated by the fan and expelled directly, generating the greater part of the thrust, around of the 80% in the engine's most modern, of manner silent and efficient. The rest of the air, the flow primary, is compressed. It passes by a series of discs, rotating with blades small, the compressor, that it squeezed to pressures tens of times superior to the atmospheric. This air, dense and hot, enters in the chamber of combustion, where itself injects a fine spray of fuel and itself ignites. The explosion controlled resulting produces gases to a temperature and speed enormous. These gases, in their path of exit, pass by other series of discs with blades. The turbine. Their mission is crucial. To extract energy of the gases, furious for to move through of an axis both the compressor to the front as the most important, the enormous fan. It is a cycle self-sufficient. The combustion moves the turbine that moves the compressor and the fan that put more air for the combustion. Finally, the gases residual still to great speed exit by the nozzle, contributing with the thrust remaining. The genius of this design of high bypass is its economy. At moving a mass gigantic of air to a speed moderate, the bypass, it is much more efficient and silent than a reactor pure that expels a mass small to speeds extreme. An engine like the General Electric GE90 that propels to the Boeing 777 can generate a thrust of more than 515 kilonewtons, sufficient for to lift the weight of 50 automobiles familiar, and it does consuming less fuel by passenger kilometer than a car modern in highway. The choreography of the flight from the asphalt to the sky and of return. With the scenario ready, the forces understood, the wings transformable, the engine roaring, it is moment of to witness the choreography complete. The first choreography is the of the takeoff. In the cabin, the pilots configure the flaps to a position specific. The tower gives the authorization. The hands themselves rest over the sticks of power and then push completely toward forward, selecting the regime toga, takeoff/go around. The engines accelerate until a roar dull and powerful. The airplane begins to roll, first slowly, then with an acceleration that you presses against the seat. The first official goes announcing the speeds critical, 80 knots, a control of instruments. Then arrives V1, the speed of decision. By below of it, you can abort the takeoff if there is a failure. By above, you are committed to take off. The track already not is sufficient for to brake. Some seconds after VR, speed of rotation. The commander pulls soft but firmly of the side stick or the column of control. The nose itself elevates. The angle of attack increases. The train principle leaves of to touch the asphalt. Some seconds more, and the train of nose also itself separates. The airplane has left the ground. The flaps themselves retract gradually and begins the ascent initial, an angle of 10 to 15 degrees toward the sky clear. Once overcome the phase of ascent initial, the airplane itself directs to its altitude of cruise, typically between 9,500 and 12,000 meters. Here itself reaches the balance perfect. The air is so thin that the resistance itself reduces drastically, but still there is enough for that the wings work and the engines breathe. It itself flies by over of the weather stormy. The pilot automatic itself activates, maintaining with precision millimetric the attitude and the course. The consumption of fuel is optimum. To measure that the airplane itself lightens burning fuel, it can perform a step climb or ascent step, climbing to a level of flight more high for to fly even more efficiently. It is the realm of the monotony glorious, where the machine fulfills its purpose during hours with a tranquility almost bored. The last choreography is the most delicate, the landing. All is reduction and precision. The pilots reduce the power and initiate the descent from the altitude of cruise. In the approach final, configure the airplane, flaps to maximum extension, train of landing down. This maximizes the lift and the resistance, allowing a speed low and controllable in the path of glide, a path invisible of 3 degrees toward the track. The airplane itself converts in a glider heavy and powerful. To only some meters of the ground itself executes the maneuver more subtle, the flare or rounding. The pilot lifts smoothly the nose, reducing the angle of attack and the rate of descent to achieve a contact soft with the wheel's principle. In the instant of the contact, the spoilers themselves deploy automatically, killing the lift and anchoring the airplane to the ground. The reversers themselves activate. Some gates in the engines redirect part of the flow of thrust toward forward, generating a force of braking brutal. Together with the brakes of the wheels, they achieve to stop to the Titan in a fraction of the distance that it used to take off. Of the fury controlled of the takeoff to the contention elegant of the landing, each movement is science applied, beyond of the basic stability, materials, and the future. But an airplane not only must to fly, it must to want to fly straight. That quality itself calls stability inherent. The design classic, with the wings in the center, the tail back, and the weight distributed, creates a balance. The plane of tail horizontal, stabilizer, and elevator acts like a small wing inverted, generating a force toward down that counteracts the tendency natural of the airplane to dive, to lower the nose. It is a system self-corrector. If the nose goes up too much, the force in the tail increases, pushing it toward down of again. It is the engineering anticipating itself to the error. The materials have been another revolution silent. From the linen and the wood of the Flyer, we passed to the aluminum that dominated the Century 20. Today, airplanes like the Boeing 787 Dreamliner and the Airbus A350 are built in more than a 50% with composites of fiber of carbon. These materials are more light, more strong, and not themselves fatigue like the metal. They allow cabins pressurized to greater altitude with greater humidity, reducing the jet lag, windows more large, and the efficiency of fuel very superior. The airplane not only flies, it flies better, more clean, and with greater comfort thanks to the chemistry of Vanguard. And the future already is in the chalkboards of design and in the tracks of test. Themselves loom engines with relations of bypass even greater, some without the cover exterior traditional open rotor. Themselves explore designs disruptive, wings ultra-long and thin tied with struts to reduce the resistance, or even fuselages integrated where the body and the wings themselves melt in a single shape aerodynamic. The objective final is the decarbonization with a bet firm by the fuels of aviation sustainable and to more long-term by the propulsion electric or of hydrogen for distances short. The trip that began with a dream and 12 seconds of flight unstable is far of to finish.